All right, so before we can get into the nitty-gritty of our notes, we have to first review long division. Do you guys remember long division from elementary school?
I didn't really know how to do that. I was really good at it in 3rd grade, and then I forgot the next year.
So,
I could do it for my family. I was so good at it.
1803, that is what we call our dividend. That's what we're trying to divide into. Our 17 here, this is our divisor. That's what we're trying to divide by. Do those words at least sound familiar? Like, hey, I heard that before in my lifetime. All right, so our long division looks kind of like a radical sign, but it's not actually a radical sign, it's long division. And true story, whenever I have to divide numbers, I picture the long division bar in my head and go through the process. That's how I divide stuff in my head. So remember, we're looking at our divisor, and then we start with the number 1, and we ask ourselves, can 17 divide into 1? No. So then we add 8 into it. Can 17 go into 18? Yes. How many times? Once. So we put a 1 up there. And then what do we do with the 1? 1. We multiply it by the 17. And we put our 17 down there. And then what do we do with the 18 and the 17? Subtract them. So that gives me a 1. And then I bring down my next number. And I ask myself, can 17 go into 10? No. So what goes up top? 0. Because no, it can't. So then I bring down my 3. Can 17 go into 103? Yes. 6 times. So 6 times 17 gives us 102. So we subtract that and we get 1. 1. And what was 1 called? The remainder. So a lot of times you'd write the little R1. Remember the little R1, like the good old days? The remainder of 1. But then like 3rd grade, they made you do long division, but then they had you continue with decimals. So since you had something left over, you'd put 0.0 and bring it down. You keep going to get your decimal. Good old days. Now, the way we would check our answer is by taking this number, which is our quotient. 106 is referred to as our quotient. We would take the 106 and we would multiply it by 17, which was our divisor. You guys remember how to multiply 3-digit and 2-digit numbers? 7 times 6 is 42, so I put down the 2, carry the 4. 7 times 0 was 0, but then I would add 4, so I'd get 4. 7 times 1, 7. And then what do I do? Because now I'm going to multiply with the 1. Put a 0 there. So 1 times 6 is 6. 1 times 0, 0. 1 times 1 is... Add them together. We get 2, 0, carry the 1, 8, 1. Add in that remainder. And we get what we started with. It was a long time ago. So I go back to this because we're going to do long division with polynomials. Yeah, it's going to be good times. So you're going to get situations where you have a polynomial like number 6 in your warm-up. You can't factor it, but you still need to divide it by something else. Long division is our method that we're going to use to do that. So these are just notations that they like to use. F of x is just referring to your dividend. What is it that you're dividing into? So my dividend up above, remember, was the 1803. So now it's just going to be a polynomial. D of x refers to the divisor. What is it that you're dividing by? Q of x is your quotient, and then R of x is your remainder. So the nice thing is that they kind of use those letters to help you out. Q of x, quotient, R of x, remainder. All answers can always be checked by multiplying your divisor times your quotient. Divisor multiplied by quotient, and then plus your remainder. Should bring you back to where it is that you started from. And then my little note there, we'll talk about this a little bit more. But R of x equals 0. So if R of x equals 0, that means if your remainder equals 0, then the divisor is a factor. Of your dividend. So if we divide and we get a remainder of 0, that means the divisor was a factor of the dividend. Again, we'll talk about that a lot throughout the notes, so we'll get that. So let's go to our first one. We're dividing by x minus 2, so that's going to go out front. Underneath our long division bar, we'll put the polynomial. We're trying to divide it into our divisor, our dividend. 6x cubed minus 19x squared plus 16x minus 4. So there's our setup. So our steps. Step 1, divide the first terms and line up in quotient. So when I say divide those first terms, I'm referring to the first term from the dividend and the first term from your divisor. And again, this is just a strategy to help you figure out what your quotient is going to be. So we start off by dividing those first two. So 6x cubed divided by x gives us what? 6x squared. So that goes up there. That's the first part of my quotient. Any questions so far on how I got that? Okay. So step 2, multiply by all of your divisor. So in this case, our divisor is 2 terms. It could be 3 terms. But you're going to multiply by all parts of the divisor. Just like before with our number, we took our 1, we multiplied it by the 17 and wrote that underneath. We're going to take our 6x squared. We're going to first multiply it by x. So that gives me a 6x cubed. But I'm also going to take that 6x squared and multiply it by negative 2. So I get a negative 12x squared. You have to multiply it by all parts. We used the first one to figure out what we wanted, but we multiply it by both parts. My number up here, I multiplied it by both parts of my divisor, the x and the minus 2. Step 3, we're going to subtract. I put parentheses around it. Just remember, I have to subtract both parts of it. So 6x cubed minus 6x cubed cancels out, which is what we want to have happen. I'm subtracting a negative 12, so that really means I'm adding that. So negative 19x squared plus 12x squared gives me a negative 7x squared. Step 4, you're going to bring down your next term. So my next term would be that 16x, so I'm going to bring that down. So I now have negative 7x squared plus 16x. And then we end up repeating that process again. So this time, though, my first term is this negative 7x squared. I'm going to divide that by x. So what does that give us when we divide those? Negative 7x. So that goes up top. That's the next part of my quotient. So again, I'm going to take that negative 7x and I'm going to multiply it by both parts of my divisor. So negative 7x times x gives me negative 7x squared. Negative 7x times negative 2 gives me a positive 14x. So after we multiply, our next step is to subtract them. When I subtract that negative 7x squared, it ends up canceling out. My 14x would become negative, so 16x minus 14x would make that a 2x. Bring down my last term, so it's 2x minus 4. And we got to do it one more time. So 2x divided by x gives us a 2. So a positive 2 is the last part of our quotient up there. So now we multiply 2 times x is 2x. 2 times negative 2 gives me a negative 4. Subtract them. And this time when we subtract, what ends up happening to our x's and our 4's? They all cancel out, so you're left with 0. So I put a smiley face in there because that means there's no remainder for this one. So our answer is just this. That's our quotient. That is the whole reason we did this long division, was to find that answer right there. And again, sometimes you might see the notation where they refer to that as cube of x. So that's our quotient, that's our answer. Problem's done. And it's called long division because it takes forever. Questions about the process? All right, let's try it again. We can probably get one more done before we go to lunch. So let's look at letter A down below. So again, we'll set up our long division bar. I got my x minus 10 on the outside. That's my divisor. My dividend's going underneath, 2x squared minus 23x plus 17. So again, our first step, take those first terms, so our 2x squared and our x, and divide those. What do we get when we divide those? 2x. That's our first part of our quotient. What do we do now with that 2x? Yeah, multiply it by this. So 2x times x is 2x squared. 2x times negative 10 gives me a negative 20x. So then we'll subtract our 2x squareds. Cancel out and become a 0. My 20 is going to turn positive, so when I combine that with my negative 23x, I get a negative 3x. Bring down our 17, so we have negative 3x plus 17. So what's going to be the next part of our quotient? Negative 3. So we divide that negative 3x by that first part of our divisor by the x. So we left with negative 3. So that's the next part of our quotient. Multiply those. Negative 3 times x is negative 3x. Negative 3 times negative 10 is 30. Does it work out so nice this time? No, we end up with a remainder this time. So when I subtract, our x's cancel. My 30 turns negative, so I get a remainder of negative 13. So the way we write our answer is we have our quotient up top, our 2x minus 3. When we have a remainder, though, because this remainder is a negative, we would write it as minus 13 over x minus 10. You always write it as over whatever you're dividing by, your divisor there. It would be plus the 13 over x minus 10. Yep. All right. Go ahead, try letter B. See if you can set it up, start it. Let's see how far you can get. All right, so how did we do with that last one? Did we get it? All right. So a little note for us to make down here. Long division always works. No matter what degree polynomial you're dividing by, whether you're dividing by an x to the first, so you're linear, you're dividing by x squared, x cubed, long division will always work for you. So we got one more long division problem we're going to do on the top of the back page. This one is a little bit different, because if we look at the top there, our dividend, is there anything missing? X cubed. We got x to the fourth, it skips over x cubed, and it goes down to x squared, and then x, and then our minus 5. If you're ever missing a term, you need to fill it in with a 0 placeholder. So we would still set up our long division just like we normally would, but after our x to the fourth, we're going to put in a 0x to the third. Because if we're missing a term, we've got to have a 0 placeholder for it. Even if it's the last term, our constant there, you still would have to have a 0 placeholder if that was missing and it just had x's in it. All right, so same process. Let's see what we can remember even after going to lunch. What's going to be our first number up top? X squared. So then x squared times x squared is x to the fourth. X squared times that minus 2 would give me a negative 2x squared, so I'm going to line that up underneath my 1x squared from the original. So when we subtract, my x to the fourths cancel. I end up getting a 3x squared. And so in this case, it didn't affect our answer that we didn't have our x cubed. But in other cases, it would. Let's say, for example, and you don't have to write this, but let's say that was an x squared minus 2x that we were trying to divide by. When I would multiply here, my x squared times my x squared, x to the fourth, and then it would have been minus a 2x cubed. So you would have needed that x cubed up above to be able to combine your like terms. So in this problem, it didn't affect it. In other ones, it could and will. So you got to make sure you have any missing values there. So continuing on, 3x squared plus x, that's what we're now looking into. So what is going to be the next part of our quotient? Plus 3. So we end up giving 3x squared minus 6 when we multiply, so that really means my minus 5 should have also been brought down, so I brought that down too. So we'll subtract those ones, and we end up with an x plus 1. Can I divide x by x squared? No, I can't do that. So my remainder is actually going to be a binomial this time. So it's going to be x squared plus 3 plus the x plus 1 over x squared minus 2. So whatever you're dividing by, you go as far as you can possibly go. Everything else is your remainder if there's anything left. So our next kind of division we're going to look at is our synthetic division. This is a little shortcut for our long division. But like most shortcuts, there are limitations to it. As I said, long division is always going to work no matter what kind of polynomial you're dividing by. Synthetic division only works if you're dividing by an x to the first. So it only works if you're dividing by a linear factor. Synthetic division will not work if you're dividing by x squared or x cubed or anything else. It can only be x to the first. So again, same thing happens. You're going to be dividing. You're going to get your quotient. You'll find a remainder if there is one. If your remainder is a 0, that means the divisor was a factor of the original polynomial. Well, let's see how this works. So we already divided this one on the front page. This was our first one. So instead of sitting here and going through it again, somebody flip to the front. What was our answer for that one? Thank you. So that was our answer when we did our long division. That was the first one when we were learning our process for it. So for our synthetic division, our little shortcut here, whatever you're dividing by, first thing you'll do is you'll set that equal to 0, and you'll solve and actually get the root for it. When we do synthetic division, we use the root instead of the factor. Long division uses the factor. We use the root in synthetic. So a little top left corner box happens there, and that's where my root goes. So with synthetic division, all we use are the coefficients, and we put them in order. So the polynomial I'm trying to divide into, I'm going to put those coefficients there. So I'm going to have 6, negative 19, 16, and negative 4. And then intentionally put a little space and a line underneath them. So our first term always just gets brought down. So our 6 is going to get brought down in this one. So now what we do is we're going to do 6 times the 2. That gives me a 12. And that goes under my next number. And now we add. So negative 19 plus 12 gives me negative 7. And then we repeat that. So now negative 7 times my 2 gives me a negative 14. Add 16 plus negative 14 gives me a 2. And repeat again. So 2 times 2 gives me a 4. Negative 4 plus 4 gives me a 0. So I put a smiley face. This last one is your remainder. The last number is always your remainder. So again, we have a remainder of 0. When we did long division, we had a remainder of 0. Synthetic division, remainder of 0. So that's how we know we did it correctly. So the way we write our answer, polynomial started over here as an x cubed. We divided it by a linear term. We divided it by an x to the first. So that means these are the coefficients for everything 1 less than that. So this is going to start off as x squared. It's going to go down 1 less than my x cubed. And then it'd be a 7x and then a 2. There ends up being our answer for that one. Same exact answer we got on the front, just a little bit of a faster process for it. So let's try this again, but we're going to fill in our steps over on the side, so if you forget when you're doing your homework, you can go back and check. So first one, top left corner box, we'll call it. Put the root that you're trying to divide by. So for this example, we're trying to divide by x minus 4. If I set that equal to 0, I get x equals 4. So I'm trying to use a 4 as my root. Second step, line up your coefficients. of the dividend just like with long division, you do need 0 placeholders if anything is missing. So for this example, nothing's missing. It goes x squared x and then your constant term. Third step was bring down the first term. So we're bringing down that 5. That first one always just gets brought down the way it is. So then we multiply it by the root, and then we add it. So 5 times 4, 20. And then we add going down, so negative 17 plus 20 gives me 3. And then step 5 is just to repeat. So 3 times 4 gives me 12. Negative 12 plus 12 gives me 0. So again, we have no remainder. So how do I end up writing my final answer with the 5 and the 3? Yeah, 1 less. This started as x squared. So this will be 1 less, 5x plus 3. All right, let's try a few more. All right, so letter A, always check your polynomials to make sure it doesn't have any missing terms. Because a lot of people, you just kind of get in the habit and you start going with things and you miss those missing spots. Like this first one is missing your x cubed. So our coefficient should be 3, 0, negative 8, negative 11, and 1. You got to put those 0 placeholders, especially in synthetic division. It will completely throw off your entire answer if you don't. So again, bring down that first term. So we bring down our 3, multiply by 2, and then add. So then we got a 6 times 2 added to the negative 8 gives me a 4 times 2 gives me negative 3 times 2 plus 1 gives me a negative 5. We have a remainder this time. So we write the remainder same way we wrote it for our long division. So this one started as an x to the 4th. So it's going to be 3x cubed plus 6x squared plus 4x minus 3 minus 5 over x minus 2. Remainder is written the same way over whatever your divisor is. Go ahead, try letter B. How would we do with that one? X cubed minus 3x squared minus x plus 1 plus 1 over x minus, or x plus 3. All right. What about that next one, letter C? What would we put over in our top left corner? Radical 2. If I set this equal to 0 and I solve, I'd add my radical 2 over. So I'm using radical 2 as my root. So my coefficients would be 1, 0, and negative 2. Because that's missing the x term. So we got to have that 0 placeholder for that. Bring down my 1. 1 times radical 2 gives us what? Radical 2. And radical 2 plus 0 is still radical 2. So now radical 2 times radical 2. So we end up with a remainder of 0, because negative 2 plus 2 is 0. So x plus radical 2. How about letter D? What's going to go in the top box? 3i. Remember how much you guys love I. So 109, those are our coefficients. So we bring down our 1. 1 times 3i. 3i. And then I add that to 0, so I still get 3i. Over on the side, if you need to, 3i times 3i, what does that equal? Negative 9. Because remember, it's 9i squared. I squared equals a negative 1, so that means it's really a negative 9. So it ends up being 0. So x plus 3i. Now really, there was kind of a hint that those were going to be the answers to begin with. Do you remember what we call these things? Negative radical 2 and positive radical 2. Ooh, you're close. It begins with C, yeah. Conjugates. Remember that word? Conjugates. They can't go anywhere without the other one. They can't go to the bathroom alone. So if one of your roots is radical 2, the other one is going to be negative radical 2. They go together. One of them's 3i, the other one is negative 3i. So the fact that one of our factors here was x minus 3i, I already knew the other one was going to be x plus 3i. I just had to have the correct work to show me how we got there. Same thing with this. Since this one was here, I already knew that that other one was going to have to go there because they're conjugates. Can't travel alone. All right, go ahead, try letter E, do the synthetic division. We'll talk about the find f of negative 3 in a second. How do we do? 2x squared plus x minus 3 plus 4 over x plus 3. What do we got? Yes. Okay. So let's say f of x is the polynomial 2x cubed plus 7x squared minus 5. So our dividend from letter E there. Let's say that's our f of x. Go ahead, plug in a negative 3. Let's see what happens. So plug negative 3 in for our x's. So 2 times negative 3 cubed plus 7 times negative 3 squared minus 5. Anybody get it yet? 4. So thinking back to our functions unit, back to unit 4, what point do we know then is on our graph? If I plugged in a negative 3, got a 4, that means we got that point negative 3, 4 is on our graph. That's like here-ish. And then the rest of the graph would be there. Is it a coincidence that when I divided by negative 3, my remainder was also 4? Think it's a coincidence or do you think it's a pattern? It's a pattern. So you plug your number in, this is your remainder all the time. You didn't even know it. You had no clue, but that was always your remainder that you were actually ended up finding. So that connects us to our last part for today, our remainder theorem. So a remainder can be obtained by doing long division, seeing if you have anything left, doing your synthetic division, seeing if there's anything left, or by using our remainder theorem. So the remainder gives us the value of y of the function f of x when x equals a k. So meaning if I plug a number in, so let's say I plug in a 5, I get 4 as my answer. My 4 is my remainder. So that is what that is saying there. It ends up being a point on our graph. Couple of things to keep in mind though, if our remainder ends up being a 0. So if your remainder is a 0, that means whatever value it was that you plugged in is a 0 of your polynomial function. So it's going to be somewhere on that x-axis. If the remainder ends up being a 0, then the point, that number comma 0 is one of your x-intercepts, which as we know is the same thing as a 0. And then the last part is if you have a remainder of 0, that means the initial thing, x minus k, whatever that number was, that is a factor of the polynomial itself. So there's 3 things that we can learn if we end up having a remainder of 0. So 3 things that we can do. If we're asked, is x plus 3 a factor of x cubed minus 7x plus 6? We have 3 ways that we could figure that out. First way, we could do long division. Is the remainder equal to a 0? If the remainder is a 0, then yes, it's a factor of the polynomial. Second way, we were just practicing synthetic division. Again, is your remainder a 0? Yes or no. If it is, then it is a factor. If it's not, then it's not a factor. But the 2 downsides to long division and synthetic division would be what? Time consuming. So can you do it? Yeah, absolutely. Go for it. Well, those ones kind of take a little while. If you just have the quick question of is this a factor, yes or no, then you want to go with the remainder theorem. The remainder theorem is going to be much faster to be able to answer that quick question for you of is it a factor or is it not a factor. So like we were doing with our synthetic division, you take whatever it is you're trying to figure out. So our x plus 3, you would set it equal to 0. You actually end up using the negative 3 instead. You use the root value for it. And then you just plug it into the function. So again, we're using this function here. So we'll plug negative 3 in for x. So negative 3 cubed minus 7 times negative 3 plus 6. We'll combine everything up, simplify that up, and see what we get. Negative 3 cubed would be negative 27 plus 21 plus 6. So that gives us a 0. So remember, the answer when we plug that in, that is our remainder. So do we have a remainder? No. So then x plus 3 is a factor. Because we got a remainder of 0, that means x plus 3 is in fact a factor of that. So that's just the quick way to be able to check. Plug the number in, see if you get a 0. If you don't get a 0, not a factor. So example 3, this is the other time when we would want to use the remainder theorem. So they've given us the polynomial f of x there. They want to know what is the remainder of f of x when it is divided by x plus 2. So to use our long division or our synthetic division, we would have to square this, and then multiply it by that, and then cube that, and then multiply all that out. No, thank you. That's a lot more work, and you're a lot more likely to make a little mistake with something. So since all they want is the remainder, again, set the divisor equal to 0 to figure out what your root value is. So in this case, it's negative 2. Plug that in for your x. So we're plugging in that -2 for the x's and all those parentheses there. So let's see, this is 1 squared times -5 times -1 cubed. So what ends up being our remainder? 5. So again, we could do that because all they want is the remainder. They didn't care about any other part of the answer. All they wanted to know is what is our remainder. Our remainder here is a 5. So that's our quick little shortcut just to get to that part. And then our last one for today, we have find c so that the denominator will divide evenly into the numerator. So for this one, we got 2 ways we could figure this one out. Only 2 because long division, that's not going to help us figure this one out. But our synthetic division or the remainder theorem will help us figure this one out pretty well. So if we want it to divide evenly, that means our remainder is a what? 0. Divide evenly means I want to have a remainder of 0. So using the remainder theorem, set my divisor equal to 0. So that means I'm going to want to use a 3. So I'll plug a 3 in for all of my x's. And then I set it equal to 0 because I want it to divide evenly. I want that remainder of 0. So setting it equal to 0 will then let me solve for c. So let's see here. 3 cubed, 3 squared times 5, 45. C equals 0. So 25 minus 45 plus 9. What does that give us? -9. So -9 plus c equals 0. So c equals 9. So if c is a 9, we have no remainder. So just to show you the other way, your other option, again, is your synthetic division. You would set it up with c in there still. C happens to be our constant term in this one. Again, you do the process the same exact way. So bring down your first term. Then you multiply times the 3. Add going down, so we have a -2 there. Times the 3 gives me -6. Add going down. Times the 3 gives me -9. So then all you have to remember is what would I add to -9 to make this my happy smiley face of 0? It would have to be 9. So either way, you still end up with the same answer. You can use remainder theorem set equal to 0. I think that one's kind of the faster way to go about it. Or you can use your synthetic division for it.